When installing a home standby generator and integrating circuits from multiple electrical panels to a single transfer switch, several options exist. These options include using a subpanel with a transfer switch, employing two transfer switches, or running a branch line from the main panel. Firstly, consider the subpanel with transfer switch option. This involves installing a subpanel outside, near the generator. The air conditioning unit and water heater circuits from the outside panel are then connected to this subpanel. Following this, a transfer switch is installed within the subpanel to connect the subpanel circuits to the generator. Finally, the subpanel is connected to the generator itself. Secondly, the two transfer switches option involves installing a transfer switch in the main panel for the inside circuits. A separate transfer switch is installed in the outside panel specifically for the air conditioning unit and water heater circuits. Both transfer switches are then connected to the generator. Thirdly, the branch line from the main panel option begins with installing a junction box in the main panel. The air conditioning unit and water heater circuits from the outside panel are connected to this junction box. A branch line is then run from the junction box to the main panel transfer switch. Now let's delve into a step-by-step guide for option 1, the subpanel with transfer switch. Remember safety first, so always begin by turning off the power to both the main panel and the outside panel. Next, disconnect the air conditioning unit and water heater circuits from the outside panel. With the power safely off and circuits disconnected, install the subpanel in a convenient location, ideally next to the generator. Once the subpanel is securely mounted, connect the air conditioning unit and water heater circuits to it. After that, install the transfer switch inside the subpanel, ensuring it is properly mounted and grounded. Connect the subpanel to the generator, following the manufacturer's instructions for both the generator and the transfer switch. Finally, once all connections are made and verified, turn the power back onto the main panel and the outside panel. Some important tips to keep in mind include ensuring that the transfer switch is appropriately rated for the total load of all connected circuits. Overloading the transfer switch can lead to overheating, damage, or even fire. Always employ proper wiring techniques and adhere strictly to all local electrical codes. Electrical codes are in place to ensure safety and prevent hazards. Consider installing surge protectors for sensitive electronics. Surge protectors can help safeguard your valuable electronics from voltage spikes that can occur during power outages or generator startups. Carefully consider the generator's fuel capacity and operating time when selecting circuits to power. Prioritize essential circuits to ensure the generator can provide power for an extended period. Selecting the appropriate wire gauge for each circuit is critical for safety and performance. Consult the National Electrical Code, specifically Table 310.15b16, to determine the appropriate capacity for conductors based on their size, insulation type, and installation method. Ensure all wiring connections are secure and properly torqued. Loose connections can create resistance, leading to heat buildup and potential fire hazards. Use appropriate connectors and terminals that are listed for the specific application. Avoid using wire nuts for connecting large gauge wires or making connections in high vibration environments. Clearly label all circuits and components within the subpanel and transfer switch. Proper labeling makes it easier to identify and troubleshoot circuits in the future. Inspect the wiring and connections regularly, especially after the first few hours of generator operation. Check for any signs of overheating, loose connections, or insulation damage. Ensure the generator is properly grounded according to local electrical codes and manufacturer's instructions. Proper grounding helps protect against electrical shock and equipment damage. Consider installing a remote monitoring system that allows you to monitor the generator's status, fuel level, and performance from a remote location. Remote monitoring can provide valuable insights and allow you to proactively address any issues. When connecting the generator to the transfer switch, use flexible conduit to allow for movement and vibration. Rigid conduit can transmit vibrations and potentially damage the generator or transfer switch. Use a properly sized and rated disconnect switch between the generator and the transfer switch. The disconnect switch allows you to safely isolate the generator from maintenance or repairs. Before starting the generator, make sure all connected appliances and devices are turned off or disconnected. This reduces the load on the generator during startup and prevents potential damage. Allow the generator to warm up for a few minutes before applying a load. This allows the engine to reach its optimal operating temperature and reduces wear and tear. Avoid overloading the generator. Check the generator's nameplate for its maximum output capacity and stay within those limits. If you need more power, consider upgrading to a larger generator. Perform regular maintenance on the generator, including oil changes, filter replacements, and spark plug inspections. Regular maintenance helps ensure the generator operates reliably and extends its lifespan. Store the generator in a well-ventilated area, away from flammable materials. Generators produce exhaust fumes that can be harmful if inhaled. Also, ensure the generator is protected from the elements to prevent corrosion and damage. Familiarize yourself with the generator's operating manual and follow the manufacturer's instructions for starting, stopping, and maintaining the generator. The operating manual contains valuable information about the generator's features, capabilities, and safety precautions. Consider installing a carbon monoxide detector in the area where the generator is located. Carbon monoxide is a colorless, odorless gas that can be deadly. A carbon monoxide detector can alert you to the presence of this gas and give you time to evacuate. When selecting a transfer switch, choose one that is compatible with your generator and electrical system. Transfer switches come in different types and ratings, so it's important to choose one that meets your specific needs. Consider installing a load management system that automatically sheds non-essential loads when the generator is running. A load management system can help prevent the generator from being overloaded and extend its operating time. Consult with a qualified electrician to ensure that your generator and transfer switch are installed properly and safely. A qualified electrician can assess your electrical system, recommend the appropriate equipment, and perform the installation in accordance with local electrical codes. When running a branch circuit, use the correct type and size of wire for the intended application. Refer to the National Electrical Code for guidance on wire selection and installation. Avoid running branch circuits through walls or ceilings without proper protection. Use conduit or cable trays to protect the wires from physical damage. Ensure all junction boxes are properly sized and rated for the number of conductors and connections. Overcrowded junction boxes can lead to overheating and potential fire hazards. Use appropriate connectors and terminals for making connections in junction boxes. Avoid using wire nuts for connecting large gauge wires or making connections in high vibration environments. Clearly label all branch circuits and components within the junction box. Proper labeling makes it easier to identify and troubleshoot circuits in the future. Inspect the wiring and connections regularly, especially after the first few hours of generator operation. Check for any signs of overheating, loose connections, or insulation damage. When connecting to existing circuits, verify the polarity and voltage before making any connections. Incorrect polarity or voltage can damage equipment and create a safety hazard. Use a voltage tester to verify the voltage and polarity of each circuit. Before working on any electrical circuits, always turn off the power at the breaker panel. Use a voltage tester to confirm that the power is off before touching any wires or components. Wear appropriate personal protective equipment, such as safety glasses and gloves, when working on electrical circuits. Safety glasses protect your eyes from debris, and gloves protect your hands from electrical shock. Be aware of your surroundings and avoid working in wet or damp conditions. Water and electricity are a dangerous combination. If you are not comfortable working on electrical circuits, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it's important to take the necessary precautions to protect yourself and others. Follow all local electrical codes and regulations. Electrical codes are in place to ensure safety and prevent hazards. When in doubt, consult with a qualified electrician. Now let's talk about transfer switches in more detail. There are two main types of transfer switches: automatic and manual. Automatic transfer switches automatically switch the load from the utility power to the generator power when a power outage occurs. Manual transfer switches require you to manually switch the load from the utility power to the generator power. Automatic transfer switches are more convenient, but they are also more expensive. Manual transfer switches are less expensive, but they require you to be present to switch the load. The choice between an automatic and manual transfer switch depends on your individual needs and preferences. Consider the frequency of power outages in your area, your budget, and your ability to manually switch the load. When choosing a transfer switch, it's important to select one that is properly sized for your generator and electrical system. The transfer switch must be able to handle the full load of the circuits that you want to power with the generator. Consult with a qualified electrician to determine the appropriate size transfer switch for your needs. Consider the location of the transfer switch. The transfer switch should be installed in a dry, well-ventilated area that is easily accessible. The transfer switch should also be located close to the generator and the main electrical panel. When installing a transfer switch, it's important to follow the manufacturer's instructions carefully. Incorrect installation can damage the transfer switch or create a safety hazard. Hire a qualified electrician to install the transfer switch if you are not comfortable doing it yourself. Regularly inspect the transfer switch for any signs of damage or wear. Replace the transfer switch if it is damaged or worn. A properly maintained transfer switch will ensure that your generator can provide power reliably during a power outage. Now let's move to generators. Generators are rated in kilowatts. The kilowatt rating of a generator indicates the amount of power that the generator can produce. Choose a generator with a kilowatt rating that is sufficient to power the circuits that you want to power during a power outage. Consider the type of fuel that the generator uses. Generators can use gasoline, propane, or natural gas. Gasoline generators are the most common type of generator. Propane generators are more expensive than gasoline generators, but they are cleaner burning. Natural gas generators are the most expensive type of generator, but they are the most convenient to operate because they can be connected directly to your natural gas line. Consider the noise level of the generator. Generators can be quite noisy. If you are concerned about noise, choose a generator with a low noise rating. Consider the features of the generator. Some generators have features such as electric start, automatic voltage regulation, and low oil shutdown. These features can make the generator easier to use and more reliable. Perform regular maintenance on the generator, including oil changes, filter replacements, and spark plug inspections. Regular maintenance will help ensure that the generator operates reliably and extends its lifespan. Store the generator in a well-ventilated area away from flammable materials. Generators produce exhaust fumes that can be harmful if inhaled. Also, ensure the generator is protected from the elements to prevent corrosion and damage. Familiarize yourself with the generator's operating manual and follow the manufacturer's instructions for starting, stopping, and maintaining the generator. The operating manual contains valuable information about the generator's features, capabilities, and safety precautions. Consider installing a carbon monoxide detector in the area where the generator is located. Carbon monoxide is a colorless, odorless gas that can be deadly. A carbon monoxide detector can alert you to the presence of this gas and give you time to evacuate. Consider the environmental impact of the generator. Generators produce emissions that can contribute to air pollution. Choose a generator that is certified to meet EPA emission standards. Also, properly dispose of used oil and other fluids from the generator. Follow all local environmental regulations. When choosing a generator, it's important to consider your individual needs and preferences. There are many different types of generators available, so it's important to choose one that is right for you. Consult with a qualified electrician to help you choose the right generator for your needs.